We've been creating classes, and what we're going to do now is see how to create them using memory called the heap. So basically you have the heap, you have the stack. With the heap, you can create basically larger allocations of memory and use them, but it requires a little bit more maintenance in regards to C++. And the way to do that is through pointers. So we're going to see how to create our class instances using pointers, and I'm just going to put a comment here. And the way we're going to do this is I'm going to create a new type, and we're going to call this MP, or like that, for pointer, so math pointer. And we're going to designate our pointer with a star. And then what we're going to do is create our object, and it's going to be done a little bit different. So we're going to do this new keyword here, and then we're going to call our type and pass in these two variables, A and B. So that creates a new object for us. Now we can basically use this object the same way we've used our other objects. So if I take our output here and just paste it down here and do a little bit of changing on this so that we are using our MP object, and paste here and here. All right, so we're not quite done. If I try to run this, you'll see we're going to get an error, and it's pointing to the way we're referencing these properties on our MP object. It's telling us math star is a pointer, did you mean to use, and it has our dash hyphen, which we have seen, and we can see that we made use of it here. And so down here, that's the same kind of syntax it's wanting us to use, but kind of in a different way. It's wanting us to use here to point to these properties because of how we've created this MP object. So if I change this out, run it, and we get our output that we're expecting. Now we've created this object, we also have to manage it, and that means we need to delete the object when we're done. So in this case we are, and we're going to just do a delete MP like that and save. So if I run that, and our object will be gone, and if we try to do something with it, so, and this will throw an error, but just to show, value of MPA equals, or let's see, value after delete. All right, and save this, and if I build it, you'll notice it's going to build fine. Deleting it has an effect at runtime. It doesn't have an effect at compile time. So if I go ahead and run, so you notice here, even after we did this delete, it still prints out the value of our mp.a5 after delete. So basically what we've done is freed up the memory for MP, and it's kind of still there pointing to something. So it can be a garbage value, for example. The way to completely get rid of it is to do MP equals null. And if we run this now, we'll get a different result. So notice it's not printing out at all down here. So there's basically nothing there. So that was a pointer with classes. Now there's another way to do this, and we can declare on just say simple variables. And we're going to now look at storing references. So if I do something like this, where I create this C and do an ampersand A, this is basically adding reference of A in C. And if I go ahead and do some output on this, so if I do something like value of new variable using pointers, and so the variable is going to be the C, and if I try to do that and run it, and notice here we're not getting any kind of output. Well, actually, I'm going to go ahead and comment this out and run. So here we are. You'll notice this C right here is giving us basically a memory address. So what you need to do in this case is do what's called a dereference, where you actually get whatever that value is you want. So here's our variable, which is 5, which is what A was, and we can see A is 5 there. So we're using this special syntax with our A when we're using it with this pointer. And again, it's just pointing to something. It's not the actual thing, because you can see here we dereferenced the memory location to get the value. So we're pointing to a memory address. That's why initially we got that hex value that was output. All right, and what we're going to do now is start looking at enums. And what I'm going to do here is just create a comment and then we're going to go ahead and see what enums are all about. So an enumeration is basically a user-defined type, and it consists of a set of named integral constants that are known as enumerators. So an example of that, and I'm just scroll up a little bit, is going to be something like this. So I'll start with my enum keyword and suit, and then what I'm going to do is create some elements in here in these braces. So I'll do something like diamonds, hearts, clubs, and spades. So now I've got an enum defined, and we can also assign values to them, but by default they're going to start with 0. So if I do something like suit 1, just going to copy this, and in here I can do diamonds 1 equals 7, hearts 1, and just going to leave these as they are, then spades 1. So in this case, our diamond 1 is 7 and increments the values of all the others. So we are going to now put these into use. So I'm going to do my hearts equals hearts 1. And then if we print this out, let's do something like printing value from enum, and actually it's going to be my hearts. So let's just do that here, and my hearts. Save and run. And here we are. So printing value from my hearts. And really, if we look at this, we have 7, 8, 9, 10. We assigned my hearts the value from just hearts 1, which was an 8. So that's why we're getting this 8 down here. All right, so that includes the introduction to pointers and enums. And what we're going to do next is look at class inheritance.